All right, so I am going to go over the lesson and assignment from yesterday really quick. Yesterday's objective was to interpret and construct graphs of distance, position versus time, and speed versus time to represent the motion of an object. This is important because it allows us to visualize the relationships between distance, time, and speed. All right, so to begin, I just wanted us to be able to look at the different ways that the line could be presented on the graph. Okay, so starting with the distance versus time graph, if you have a straight line, this means that the object is stopped or at rest. And another way to say this, or that you may see this, is that the object is motionless. That means it has no motion, it is not moving. The other way you may see this on a distance versus time graph is you may see that the line is going straight up or going up or increasing distance. And we say that this means that the object is moving away from the starting point and it's moving at a constant speed. And then with the line going down or decreasing distance, we say that the object is moving back towards the starting point at a constant speed. So it's moving backwards, which is a reason for um, the distance decreasing because it's going backwards. If you see a line curved up on a distance versus time graph, this means that the object is increasing in speed. So the speed is speeding up. And if you see the line going down, that means the object is decreasing. I'm sorry, it's a curved line going down. That means the object is decreasing speed or slowing down. Now, with the speed versus time graph, if you see the line go straight across, but it's not touching um, the x-axis, then we say that the object is moving at a constant speed. So again, the line is straight across, but it's not touching the x-axis. This is an object moving at a constant speed on a speed versus time graph. But however, if the line is going straight across but touching the x-axis, that means that the object is stopped or at rest, or as we say, motionless. So it has no motion, it's not moving. And again, this is only if it is touching the x-axis like it is right here. So if the line is straight across touching the x-axis, it is not moving. If it is straight across but not touching the x-axis, it is moving at a constant speed. When you see a line going straight up or increasing distance on a speed time or increasing speed on a speed time graph, it means that the object is moving at an increasing speed. So if you see the line going up, it's moving at an increasing speed. You see the line going down, it's doing the opposite, it's moving at a decreasing speed. And then here you see line A, B, and C. So or line A and B. So line A would be have a steeper slope, which means that the line is um, traveling about the same distance in less amount of time, so lesser amount of time. So that means that it's going about the same distance, but it's taking less time to go that distance. This is called a steeper slope or steeper line, and that means that the object is moving at a faster speed. Okay, and then if you look at B, it's traveling the same amount of distance in a more amount of time. So it is what we call a shallow slope or line, and it's moving at a slower speed. So now that we know the different types of lines or slopes that we may see on our distance time and speed time graph, let's go over a little bit what a distance versus time graph even is. So a distance time graph or position time, you may also see it instead of distance, you may see position. It illustrates the distance in object traveled over time. They can be very useful when trying to compare the motion of one or more objects, and they can also be used to find the average speed of an object over a distance. So if we look at this position or distance versus time graph here, it has each line labeled, right? So let's describe the motion at each of these. So if we look at A, we see that the line is going up, and because it's a distance time graph, we know if the line is going up, that means the object is moving away from the starting point. At B, we have the line going up, straight up, covering about the same amount of distance in a less amount of time. And we know that this means that one is going up, it means that it's moving away from the starting point. And then two, it is steep, very steep, so it's moving at a faster rate. So it's moving away from the starting point at B at a faster speed. C, the line is straight across, and we know in a distance time graph, when the line is straight across, it is not moving or stopped. D, the line is moving up, but it's curved upward. And so that means the line moving up is moving away from the starting point. And because it's curving up, it's moving away from the starting point at an increased speed. So the speed is speeding up as it moves away from the starting point. And then finally, line E. Line E is going down. So that means it's decreasing distance. And we know when an object is decreasing distance, that means it's moving back towards the starting point. And because the line is straight, going straight down, it's moving back towards the starting point at a constant speed. And so this is just everything I just said. If you need to pause and go back or whatever you need to do, make sure you do that. Again, this video is yours, so pause it, rewind it as many times as you need to get an understanding of what I just said. All right, so I'm going to go ahead and move on to speed time graphs. Wait, I'm not moving on to speed time graph. So this is a try it. And you're going to just tell a story describing the motion of an object at each point on the distance time graph below. So you can pause the video and you can type in your answers or write in your answers. Just basically telling a story. So you can pretend that this is a toy car and you're describing the motion of the toy car at each point. So, for example, at A, the line is straight across. So you could say a car um, stopped for 5 seconds at a red light, and then B, the line is curved. So you could say, and then it sped up for about 5 seconds away from the red light, and so on. So you're just telling a story about the motion of an object at each of these points on this graph. All right. So now we have speed versus time graph and what it is. So a speed versus time graph, it illustrates the speed in which an object traveled over time. A speed versus time graph plots speed on the y-axis and time on the x-axis. This type of graph is very useful in determining the rate at which an object accelerates. So we know acceleration means to speed up, slow down, or change direction. Sometimes you may see speed versus time graphs called velocity versus time. Just know velocity is a change in speed plus a direction. So if we're looking for the acceleration, that is a change in velocity. So sometimes you may see it as velocity. Sometimes you may see it as speed. So looking at this speed versus time graph here, it gives us about 5 points, and it's asking me to describe the motion at each of these points. So if I look at A, this object is moving in a straight up line. So because this is a speed time graph, I know that this object is increasing speed. And because if I compare this object to the other object moving in about that same amount of time, this object is moving faster because it covered more distance in a less amount of time. So I know this is not only increasing speed, but it's also moving at a faster speed. If I look at B, I know B is increasing speed, but if I compare it to A, I know it's moving at a slower speed, but it is also, the speed is increasing because the line is straight across. If I look at C, I'm sorry, straight up. Look at C, the line is straight across. So this means that the object is moving at a constant speed. I know it's moving at a constant speed and not stop because the line is not touching the x-axis. So it's not touching the x-axis, but it is straight across. So that means it's moving at a constant speed. And then D, this object is decreasing speed. And I know this because the line is going down. E, this object is stopped or at rest. And I know this because it's a line that's going straight across and it is touching the x-axis. So when the line is touching the x-axis, it is stopped or at rest. All right. So now you're going to take your time and you're going to try it on your own. Create a story describing the motion of an object at each point on this speed time graph below. So at each point, you're going to tell a story about the motion of this object. Okay? All right. So that is that. I want to take a minute to go over the practice that went along with this lesson. If you got a chance to go through it yesterday, oops, that's not what I want to do. I want to zoom in. So for this practice, the direction says to, based on your knowledge of interpreting motion graphs, sort each description to the correct letter on the graph. So I'm going to do graph 1 with y'all, and then I want y'all to do graph 2, 3, and 4 on your own. So one thing that I just learned is that the direction that a line is going on the graph it means something about the motion of that graph, right? So when I'm looking at distance time graphs, I know if the line is going up, that means that the object is moving away from the starting point. If the line is straight across, it's stopped. If the line is moving down, it's moving back towards the starting point. And if the line is if the line is curved up, it's increasing speed while moving away from the starting point. And if the line is curved down, it's decreasing speed while moving back towards the starting point. So I know these things about distance time graph. So because I know this, I can easily find a description to match each of these, right? So if I look at line A, so one thing I want y'all to pay attention to, not only is the direction that it's moving in, but also the amount of time it took to move in that direction in the distance that it took. So the distance that it took to move in that direction in that amount of time, right? So not only are we paying attention to, like for example, that A is moving away from the starting point. We're also going to add that A moved about 5 miles away from the starting point in 5 minutes. Okay, because if you look at line A, in 5 minutes it was at 5 miles, right? So it stops at like right here at 5 minutes. So we know that. So I'm looking for the description that tells me something about an object moving away from a starting point in 5 minutes. They move 5 miles away from the starting point in 5 minutes. Okay, so I'm looking for something like that. And if I look through my descriptions, which I have to carefully read to be able to correctly choose one. And if I look at description 9, it says the car drove 5 miles in 5 minutes. The driver then thought he may have forgotten his science notebook. So the driver drove 5 miles in 5 minutes is that key thing. 5 miles in 5 minutes is that key thing in this description that helps me to know that this description is described in line A, right? Because I know that line A is moving away, right? And I know that he moved away 5 miles in 5 minutes, okay? Now, if I look at line B is straight across. So because line B is straight across, and I know on a distance time graph, a line that goes straight across means that the object is stopped, right? So my object is stopped, and if I look at the time, the amount of time that it will stop from 5 minutes to 6 minutes. So that means for 1 minute, this object was stopped, okay? So in my description, I'm looking for a description that says something about an object being stopped for 1 minute. So if I read through the descriptions, I'm looking for something that says something similar to an object being stopped for 1 minute. And if I look at description 2, sorry, description 3, it says when the driver stopped to check if his notebook was in his backpack, it took him 1 minute. The key words in description 3 are that the driver stopped and it took him 1 minute. And I know here at B, it took 1 minute. The object was stopped for 1 minute. So here for B, I'm just going to put that under there like that. My description is that the driver stopped to check his notebook to see if his notebook was in his backpack for 1 minute. Now, if I look at line C is going straight up. I know on a distance time graph, a line that's going straight up means that, again, it's moving away from the starting point. So, and it's moving at a constant speed. So if I look at C, this line is moving up, it's moving away, right? If I look at the amount of time it took about 9 minutes, and it traveled about, let's see, from 5 miles to 10, that's about 5 miles, 6 miles. Yep, so it went from here, which is 5 miles, to here, which is 11 miles. So from 5 miles to 11 miles, that is 6 miles. And then it went from 6 minutes to 9 minutes, which is 3 minutes. So in my description, I'm looking for a description that says an object moved 6 miles in 3 minutes away from the starting point. So an object that's not going backwards, but moving forward for 3 minutes, that moved forward 6 miles in 3 minutes. So if I go to my descriptions and I read all of my descriptions, and remember my line is straight up, so he's moving forward, he's not going backwards. And also it's going to match the story, right? This story is talking about a car um thinking he left his notebook. He stopped to check for his notebook. And so if I'm thinking going along with that notebook story, description 2 is going to be the description that matches for C. It says the driver realized he had his notebook, but since he stopped for 1 minute, he had to drive faster. So he drove 6 miles in 3 minutes. And this matches this because if you look at line C, he is going faster, and we know this because I'm gonna move this for a second. This line is steeper, right? Line C is steeper. If we go back to line A and think and compare it to line A is not as steep as line C. So that means at line C he's moving faster. So for C, the description, the driver realized he had his notebook, but since he stopped for 1 minute, he had to drive faster, so he drove 6 miles in 3 minutes. That is our answer. Okay. So that's all you're doing for graph 2, for graph 3, and for graph 4, okay? You're just matching the description with the correct line. And then when you get to slide 5, you're just answering 4 analysis questions. Basically just checking your understanding of what each line on a graph means, okay? So that is it for this lesson. I hope this was helpful. And I hope you have a great day.